So some more trigonometric identities using these newly defined functions, which I'm going to talk to you a lot more about. Remember, sine squared x is equal to 1. We've defined secant x as 1 over cosine x. Cosecant x is equal to 1 over sine x. And cotangent x is equal to 1 over tangent x. This is going to be equal to, remember that cosine was equal to x divided by r, so this is going to be upside down. This will be r divided by x, this will be r divided by y, and this will be x divided by y. The reason that I'm bringing this up is that there is a relationship between tangent squared x and secant squared x, which happens, it shows up in calculus all the time. And I'll tell you what, I'm going to show you exactly what I have to do. It's one of these two. It is tangent squared x plus 1 equals secant squared x, or it is tangent squared x minus 1 equals secant squared x. I actually know which one of these it is, but depending on what day it is, I forget whether it's plus or whether it's minus, and I want you to be able to figure it out. And the way that you do it is with these identities. So first, let's do this one. Write down what these things are in sines and cosines. Tangent squared x is sine x over cosine x squared plus 1. Let's see what this equals. We'll see if this comes out to the same. This is the same as sine squared x over cosine squared x plus 1. I have a fraction. I'm going to multiply the top. 1 is really 1 over 1. I'm going to multiply the top by cosine squared x, the bottom by cosine squared x, so we can have a common denominator. And now I can add across the top, and I have the bottom, the same bottom. So this is sine squared x plus cosine squared x over cosine squared x. But we know that sine x squared plus cosine x squared is equal to 1. So this is 1 over cosine squared x. This is 1 over cosine x squared. This is secant x squared. Okay, so this is the one. The reason why I put this down here is, as it happens today, the mad cow disease isn't so bad, and I can remember this. Some days I don't remember if it's plus or minus 1, and here's the deal. If your memory is a steel trap, it's okay. But if it's not, you need to know how to figure this out. In calculus, this shows up so much. If you know this, you will be so happy. You will get A's. Let's think about some more trigonometric identities. Suppose that we're trying to find some solution, and it turns out that sine squared t plus 2 sine t plus 1 is equal to 0. This is just what comes out. And incidentally, you might be thinking, where's this guy getting this? Where's this coming from? It's not even in the chapter we're in. I just made this up, and no, the fact is what I gave you for the chapter is probably all you really need. This is just extra stuff to start to get a comfortable feel for it. How are you going to solve a question like this? And the way is to think about it, I got something squared plus something to the first power plus something equals 0. Right away, you want to be thinking of quadratic equation. This looks remarkably like this. And with any luck, you know that the solution to this, x, is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to do this substitution. We're just going to let x equals sine c. And that means that we can rewrite this. If x is equal to sine t, that means that x squared is equal to sine squared t. This can be rewritten in terms of x squared plus 2x plus 1 equals 0. This is a really simple one. I just made this up. This goes fast. Hopefully you can see this is x plus 1 squared equals 0. That means that x is equal to minus 1, or sine t is equal Now we need to think about the unit circle. Your calculator will tell you where sine of t is equal to -1, but, and hopefully you already know, it's right here, right, at 3 pi over 2, or minus pi over 2, or adding 2 pi or subtracting 2 pi to either of these. These are the same address. Minus 2 pi over 2 swings down this way. Positive 2 pi over 2 swings around this way, or positive 2 pi. Positive 3 pi over 2 swings around this way. It's Friday. I'm telling you, I'm having one of those days. What are all the solutions to this, though? Remember, so what we can do is we can write it like this. One way or another, every time, every place that has this address has the form of this, 3 pi over 2 plus 2k pi, where this number k is an integer. Because what it means is that here's our initial address. This is our terminal address. If k is 1, then it just adds 2 pi and we just go bam, we land here again. If k is 2, we add 4 pi and we go 2 pi, 4 pi, we land here again. Similarly, if k is -1, -2, hopefully you can see this is true. The reason why I'm beating the bush a lot with this is going to happen when you get into your calculus class, and with any luck you'll have a good stringent teacher who's going to really make sure you understand it, because look, if you become an engineer and you're designing an airplane and I'm flying on it, I really want you to understand this. So you'll notice there's an infinite number of solutions to this, and these problems are going to be coming up shortly if they're not already in your problem set. But I'd like you to recognize this and look at this and go, oh yeah, I recognize this is some kind of quadratic equation. Lastly, we only have a few more minutes left in this section, and I'm going to give you some more advanced material, some more preview material, just so you can see this, to see what you're going to have to memorize. This just has to be put in memory, which I'm going to start now and bore you to death with this a million times, because you need to know this. Cosine x plus y is equal to cosine x times cosine y minus sine x sine y. Cosine x minus y is equal to cosine x times cosine y plus sine x sine y. So you'll notice that if you're adding angles in cosine, you end up subtracting. If you're subtracting angles in cosine, you're adding. For sine x, we have sine of x plus y is equal to sine x cosine y plus sine y cosine x. You can see these formulas have a different flavor. Here, plus is plus, and you're bouncing between sine x and cosine y. Here it was cosine x and cosine y. Sine of x minus y is equal to sine x cosine y. Once again, only this time you get the minus. Sine y cosine x. Earlier, I made the claim, and I showed you by a picture. I said that sine of x plus pi over 2 was equal to cosine x. Well, now I can show this in another way. Here is x plus y. I'm going to let this take the place of y in this formula. So this sine of x plus pi over 2 is going to be sine of x cosine pi over 2 plus sine of pi over 2 times cosine x. Cosine of pi over 2 is 0. This entire term just gets wiped out. Sine of pi over 2 is 1. This is, in fact, cosine x. Depending on who your calculus instructors are, my instructors did never allow us cheat sheets or anything. We had to memorize this. We had to know this. Especially if you're going to be a real scientist or an engineer, make sure that you memorize these. For this class, okay, so I may not be your instructor, so I won't say anything. I would recommend that you memorize these. These will be handy. And it's Friday. I get to go have a great weekend.